Find the work done by force Fxy equals 2y, comma 3x, comma x plus y. In moving an object along a curve RT, being cosine t sine t 1/6, where t is between 0 and 2 pi. So work, when we think of work here, work is done by our curve C being f dot t ds. So in that same way, we're going to use our vector field, and work is going to be calculated this way. And we can think about it from the last video that when I'm going along my path, am I going to get this pushing against me so much that I get a negative because of my vector field? So this is the idea here. So that means we're going to need the integral of C of f RT dotted with r prime t dt. So that's our formula there that we're going to use here. So if we're going to need some information, right, we're going to need our RT, which I'm just going to write these all out. I don't like the form that they have it in. Cosine t, sine t, and 1/6. So then my r prime t is going to be negative sine of t, cos of t 0. And then we have our f then, our f of rt, and that's going to be 2 sine of t, comma 3 cos of t, comma, and it's x plus y, so x plus y. So cos of t plus sine of t, and there's our f rt. So now all we're going to do is just plug everything in. And we have our bounds for our t2, that's 0 to 2 pi. So we put that in first. And then we have our f, which is 2 sine t, comma, 3 cosine t, comma, cos t minus sine t, dotted with r prime t, which is negative sine t, comma, cos t, comma, 0 dt. So that's our initial integral here. So now we've got to multiply component-wise because that's what the dot product is. So that's going to be sine of t, times negative sine of t, or 2 sine t. So that's going to be negative 2 sine squared t. And then cos t times 3. So that would be plus 3 cosine squared t. And then for the last one, it's a cos t minus sine t times 0, which is 0. So this is all I have for this problem here, dt. So now to do this problem, I would start it by hand, but I'm not going to do the whole problem by hand here. It wouldn't be too bad, I just don't feel like going through all the identities. And I just want you to see the answer for this one here. So that sine squared t, I'm going to call 1 minus cosine squared t. So it's minus 2, or negative 2, 1 minus cosine squared t, plus 3 cosine squared t dt. And this here I can distribute through and then add those together. So the integral from 0 to 2 pi. And that's going to be negative 2 plus 2 cosine squared t plus 3 cosine squared t dt. And that equals the integral from 0 to 2 pi, negative 2 plus 5 cosine squared t dt. Which this equals, when you do all the math, pi. So that's the answer, pi.